Okay, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Al-Alif Irfan and my matrix number is 199090. So today I am going to talk about fluid characteristics and directional analysis. So fluids can be either gases or liquids. A liquid is hard to compress and it takes the shape of the vessel that contains the liquid. However, it has a fixed volume and it has an upper level surface. Upper level surface means the surface of the liquid, the where's the atmospheric pressure apply. But gas is very easy to compress and it will expand to fill its container. So there is no free surface or upper level surface for gas. And liquids are generally assumed to be incompressible fluids and gases is a compressible fluid. And liquids are only compressible when they are highly pressurized. Liquids are compressed by using pump and gases are compressed by using compressor. So the most important characteristic of fluids in the viewpoint of fluid mechanics, they are density, pressure, viscosity, surface tension, and compressibility. So next is the dimensional analysis. Okay, so there are 5 basic dimensions listed below with their own SI units. This is the most basic dimension that we use in our daily life, which is mass, length, time, electric current, and temperature. These quantities that have dimensions only can be added and separated or compared with other dimensions that also have similar dimension to them. And then the dimensional analysis is a problem-solving method that uses the fact that any number or expression can be multiplied by 1 without changing its value. This dimensional analysis method is a very convenient method that we can use if we want to change uh, the value, or if we want to change the SI units. For example, inch. If you want to change 2.54 centimeters to 1 inch, we need also to subtract it with how many centimeters in a 1 inch measurement. For example, for 5 inch, we need to use this kind of formula. So this kind of formula to change from inch to cm, which is 1 inch is equal to 2.54 cm. So this is the next example where we want to change year to seconds. Then we need to compare it with other value. And the method that I said earlier, that the expression can be multiplied by 1 without changing its value, it means that this is the method that we use to change the SI unit. And then there is actually two method that is listed below dimensional analysis. One of them is Rayleigh method. So for Rayleigh method, it is the most easiest method. First, if you want to use this method, we need to write the functional relationship in the form of y is equal to k is the constant, and a, b, c, p, q, r we listed down as the power of a, b, c subsequently, consecutively. So after we write the functional relationship, we need to determine the net power of the PQR. This is very important if you want to derive a formula. And then we need to apply the principle of dimensional homogeneity, and then we solve the simultaneous equation. Later on, I will show you how it is done. Okay. So in this method, the expression for the variables in form of exponential equation and dimensionally homogeneous. And this is the same equation that you need to write down as the previous one. But this is more general, and y is the dependent variable and x is the independent variable. If we look at this the most simplified one, this is y that is dependent on the value of a, b, c, and a, b, c is the independent value. So what will determine the value of y is a, b, c, and the p, q, r is the power value that we need to determine to find out how the equation is how the equation is formed. So, but this method is only suitable to determine the expression that contains 4 or 3 variables. So it means we must not exceed 4 independent variables, because if the variable exceeds 4, we need to use another method, which is Buckingham Pi method. But I will explain to you later. Okay, first, the last one for Rayleigh method, I'm going to explain you how to derive an equation using Rayleigh method. Okay, then this is for an example of equations. So u is the velocity. We want to find the velocity, which is the y, and u is the dependent variable. So if we expand the SI unit of u velocity, we will get the distance over time. So u is dependent on p, the density, and k. So we write like the basic or the most general equation that I have explained earlier, and this is a constant, and this is the independent variable, and we put the value, the power value, and then we change it, and then we expand the variables, and after that we will compare the power, but we compare the power with the same dimension. For example, it's L is a dimension of 1, and then we compare with L -3, and then with L -1. So M, we have no M here, so it is 0, and then we have AM and BM, and then for L we have 1 here, and this is actually -3 and -3, and this is -1b, so -3a minus -3b, and then for T, -1 here, and we have no T here, but here we have -2b. So the T value is negative. So for the A, we will get -1 over over -2. So we will get 1 over 2. So B is 1 over 2, not -1 over 2. So we find out the value of A and B using the simultaneous equation, and then we put it inside back in here, and then we organize it by using the mathematical algebra, and then we will get this answer. Okay, then this Buckingham Pi method that I have explained just now, that this method is used when it involves a large number of variables. This is the x dependent variable that is dependent on the functional groups of x, x3, and until the last variable that it is dependent. So I'm going to read the step that we need to comply when using this method. So for the first step, we need to list all the variables that are involved in the problem. For example, the geometry of the system, the fluid properties, external effect. It is important that all the variables are independent, because this variable is the variable that will determine the value of the dependent variable, which is y. And then we will express the variable in terms of basic dimension. It means like we expand the variable. When we expand the variable, it is more easier for us to compare with with the dimension of the dependent variable. And the third step, we determine the member of pi terms, the Buckingham Pi theorem, how many the variables, and what is the reference dimensions. The reference dimension is dependent on the dependent variable, which is y, and k minus m is the independent dimensionless group. And the fourth step, we select a number of repeating variables where the number required is equal to the number of reference dimensions. And then we form a pi form by multiplying one of the non-repeating variables by the product of the repeating variables. Each set, all of them will be raised to an exponent that will make the combination dimensionless. And repeat the steps for each of the remaining non-repeating variables. And then we will express the final form as a relationship among the pi terms and think about what it means. This is pi 1 that is dependent on the functional group of pi 2, pi 3 and until the last. And then the actual functional relationship among the pi terms. And then that is all for the vacuum pi theorem, relay method and the fluid properties. Thank you.